Okay, let's do a quick review for the quiz. It says determine if the function shown on the graph is continuous. If not, identify the type of discontinuity and the location. All right, so here is my graph in number 1. And I have discontinuity right here, okay, because there's a hole in my graph. And so that is definitely discontinuous. So we can't think about it as jumping from one side to the other. There's a hole, which means something was removed. So this is removable discontinuity, or it can also be called point discontinuity. And I honestly do not remember what I called it on the quiz. So just know that they're the same thing and you've got to know them both. The location is not the ordered pair of the point. It's always the x value. So I'm at 1, 2, 3, 4, 5. So x equals 5. Moving on to number 2. So on this one, if I was giving you this paper quiz here, I would have changed this question because I know it's hard if you don't really know how this function works to tell if maybe this is like a little curve up here or maybe not, and it's actually not. There's an asymptote there. Okay. So since there's an asymptote, it's definitely discontinuous. And anytime you have a vertical asymptote, the type of discontinuity is infinite. And then the location, again, is the x value, so x equals -2. On number 3, I can trace the whole graph without picking up my pencil, which means it's continuous, so there is no type or location. Right? Now let's talk end behavior. In behavior, we start off by saying as x approaches infinity, f of x approaches, right? So as x gets bigger and bigger and bigger, y gets smaller and smaller and smaller, so it approaches negative infinity. And then as x approaches negative infinity, f of x approaches. Now this is the only time you go from right to left. Everything we talk about with all of our interval stuff, we go left to right and bottom to top. But when you're talking about in behavior, and as x approaches negative infinity this way, so as x gets smaller and smaller, so does y, so it approaches negative infinity. Number 5, you should be able to recognize this as an exponential graph. So there is no there's no vertical asymptote. There is a horizontal asymptote. Okay, so then as x approaches infinity, f of x approaches. Well, as x approaches infinity, y does not approach negative infinity, even though it is still getting smaller and smaller and smaller. It's approaching this asymptote, never going to get there, so we're approaching 1, 2, 3, 4, 5, 6, -6. Right? And then as x approaches negative infinity, f of x approaches. So as x gets smaller and smaller and smaller, y gets bigger and bigger and bigger all the way to infinity. Notice that that horizontal asymptote didn't affect anything. On number 6, we have 2 asymptotes. We have a vertical asymptote right here and a horizontal asymptote right here. So our vertical asymptote affects continuity. So this is a discontinuous function because there's a vertical asymptote there. So it has infinite discontinuity. It's not asking me that here, but that vertical one does nothing to end behavior because remember, we don't care about middle behavior, we care about end behavior. So the horizontal asymptote does affect end behavior. So as x approaches infinity, f of x approaches, right? So as x gets bigger and bigger and bigger, y does get smaller and smaller and smaller, but it's approaching this asymptote, which is at -1. And then as x approaches negative infinity, f of x approaches, well again, as x gets smaller and smaller and smaller, y is getting bigger and bigger and bigger, but it's approaching the asymptote, not infinity, so -1. So here we're approaching it from the top, and here we're approaching it from the bottom. Okay, so that is continuity and end behavior. Now let's look at symmetry. We're just going to look at even and odd, so we're going to ignore all of this. So I just want to know, is this function even, odd, or neither? And so this has y-axis symmetry. And so since it's a function that has y-axis symmetry, this is an even function. When I look at number 2, and ignore all that, here I have y-axis symmetry again. I also have x-axis symmetry and origin symmetry. Okay, I've got them all. So you can't be even and odd at the same time. And this one is definitely a neither, even though it is even, or it's not even, but it has y-axis symmetry and x-axis symmetry. It's not a function. So it can't be an even or odd function if it's not even a function. So this is neither. Now this says to determine algebraically if the function is even, odd, or neither, and if even or odd, we have to describe the symmetry. So to figure out algebraically if it's even or odd, I have to find f of negative x. So that's going to equal 2 times the cube root of negative x. That is 2 times the cube root of negative 1 times x. So I can take the cube root of negative 1. That gives me negative 2 times the cube root of x. It does not look the same as this, but it is the negative version of that. So that equals negative f of x, which makes this odd. And then I have to explain the symmetry. So this is symmetric with respect to the origin because it is odd. Right, so this next one, I have to find f of negative x. That's equal to negative x squared over negative x minus 1. This gives me x squared over negative x minus 1. That does not look identical to this, so I have to try to factor out a negative 1 if it wasn't obvious like this one. So this is going to give me x squared over negative 1 times x plus 1. And even if I pull this negative 1 out to the front, it's not going to give me negative f of x, so this one is neither. Okay. Then this last one, I need f of negative x, so that's equal to negative 4 times negative x to the 4th plus 13 times negative x squared minus 4. That's equal to negative 4x to the 4th plus 13x squared minus 4. So that is identical to this, so that means that equals f of x, and that makes that an even function. Right, so then I need to say that it is symmetric with respect to the y-axis. Okay, and there you go.